Hello everyone, this presentation covers Chapter 5 of Mechanics of Material, which is focused on torsion. We are from Group 14 and this presentation is prepared by our group members as listed on the slide. Torsion occurs when a circular shaft is subjected to a twisting action, such as turning a key or rotating a shaft. In this video, we will explain the concept of torsion, torque, power transmission, and angle of twist. Let's begin with torsion.
Hi, now I will explain the fundamental of the torsion. First, what is it? Torsion is twisting deformation of a shaft or component. This happens when it is subject to a pair of equal and opposite torque. We measure the resulting stress in the Pascal or Newton per meter square. So now let's look about the formula of the torsion. For a solid circle shaft, the most common case, the maximum shear stress is calculated using this core formula. Tau max equal T times C divided by J. So let's break it down. T is applied for the torque, C is the outer radius, and J is the polar moment of any shaft. The stress is not uniform, it varies linear with the distance P from the center, as shown in this related formula. But now, how do we find the J? For a solid shaft, it's pi over 2 times the radius to the first power. For a hollow shaft, we subtract the inner core. The formula becomes a pi over 2 times the difference between the outer and inner radius to the first power. So in summary, torsion causes a twisting shear stress. We calculate the maximum stress with the Tc over J, where J defines the shaft's geometric resistance to the twisting.
Have you ever tried opening a very tight bottle cap and it just won't open? But you twist harder and hold it further away, suddenly clicks, it's open. The twisting action you just saw, it's called torque. In mechanics of materials, torque is a twisting effect produced when a force acts at a distance from the axis of rotation. Torque does not just depend on force, it depends on two things: how strong the force is and how far it is applied from the center. That's why torque is defined by this formula, T equal to Fr, where F is the applied force and R is distance from the axis. Torque is everywhere around us. It's used in the car engine shafts to transmit power, in screwdrivers to tighten and loosen screws, in electric motors to produce motion. Without torque, there is no movement. Understanding torque is important because it prevents shaft failure, ensures safe power transmission, and support clean and efficient engineering.
Assalamualaikum warahmatullahi wabarakatuh and hello. Today I'll be talking about power transmission. Power transmission refers to the transfer of rotational energy through a shaft subjected to torque. For example, when a gear is moving, the rotational movement will create power, and this power will be transferred from one component to another. In terms of formula, power is equal to torque, that is usually in newtons meters, times angular velocity, usually in rad per second. Or in terms of frequency, power will be equal to 2 pi times frequency times torque, since angular velocity is equal to 2 pi times frequency. This specific formula is a bit more practical in real-life usage because usually we would find angular velocity in terms of revolutions per minute, RPM, or Hertz.
Hello everyone, today I will explain about the angle of twist in torsion. The angle of twist is the amount of rotation that occurs in the shaft when torque is applied. It shows how much the shaft twists along its line. The formula for angle of twist is theta equals to TL over Gj, where T is torque, L is the length of the shaft, G is the shear modulus, and J is the polar moment of inertia. A longer shaft will produce a larger angle of twist, while a shaft with a larger diameter and higher shear modulus will twist less. This concept is important to prevent excessive deformation and to ensure structural safety.
That is all from us. Thank you for listening.